Now that we're into classes and objects, this gets more into what C# is all about, object-oriented programming, OOP. Java is the same way. A lot of the languages now are all going to object-oriented programming just for reusability of code, easiness to read. But the architecture of a lot of this stuff, especially if you're going to stick with the web development and all that, it's a 3-layered application. Of course, the HTML, CSS, JavaScript, they took the presentation layer part of it already. The front end is, you'll hear it called a lot of times. The middle layer is where all the business classes are. That's what we're working on now, is this middle layer part of it, the C#. And then these classes and objects we're setting up makes it possible to start talking with a database. So as we're doing this, we got to kind of think that we're going to be conversing with a database. Not that we're going to start doing it yet, but towards the end of the semester, we'll actually set up a database and start querying a database, saving some results, pulling some back, updating some of the results. So when you talk about web development and all that, most of the time it's a 3-layered application. You got your presentation layer, like I said, CSS, HTML, JavaScript. The middle tier, which is the C# stuff we're learning now, or Java, depending on where you go work in the future. And then the database layer is the third part of it. They call it the back end a lot of times because it's the back part. Nobody sees it. That's where all everything gets stored and held onto. Yeah, Liam. Thank you, sir. So as you can see, they got the main Windows form class, other form classes, business classes, database classes. So that's usually the 3 levels or layers of your application, your web application. I'm not going to go through much of this slide. Just I think a lot of it gets confusing on some of the terminology in that. I think it's easier to show you how this stuff works and the terminology. And as we go through it, like the getters and setters here, you'll start seeing a lot of that in these examples. You'll learn the actual terminology for them rather than calling them getters and setters, is what you'll hear anyways out in the real world most often.
I think one of them gets it.
Yeah, and I don't like their example because they use the application they've been building all along. And so if we haven't been building it, it kind of gets confusing as how it works. So I think we're better off just doing our own. So I'm not going to follow, like I said, the slides very much on this. I'll probably start off doing a couple demos today. There'll probably be a little bit more tomorrow that I'll cover. And then hopefully I'll get it wrapped up tomorrow for the most part. And then you guys will have labs for
A year.
the next week and a half or so to get these done.
I'm totally okay with that.
And like I said, there's like 3 labs: flashcard, store inventory, bank login. Oh, I guess there is more. Game break, job estimates.
I think there's 6. Yeah.
Yeah, tile estimate. I got to keep you on your toes. Tomorrow I'll get more into reading these UMLs. I'll kind of describe them a little bit today as we go through, just so you know what's going on with these labs as we do them. So give me a second to get my stuff set up here.
The second one doesn't have a UML, which I think is super cute.
Yeah, which is funny because it's probably one of the
Harder
more
ones.
involved ones, yeah, and they don't do.
I think it's designed to make you like identify what the objects and classes are, because like everything's kind of like set in stone.
But you can put all your class. All you need is one class really for that one, and you can just call it like store inventory or
Yeah.
whatever you want, and then put everything else inside of it. But, so give me 1 second here. I need to grab one more thing out of a folder.
Are you going to be following Mr. G's example, like very closely?
The first one I won't.
Okay.
I'm
I know you're
changing.
changing it to baseball.
Yeah, from
But like the
soccer.
app will be the same.
Pretty much, yeah. And then the other ones I pretty much copy
Sure.
verbatim on it.
I just want to know if I need to make an app with one button on it, or if I need to.
Now all of them have one button.
It's
And
like one button, one label.
yeah, and then the last one, the painting one, I think has 3 text boxes or something like that. So if you want to code along, you're more than welcome to. If not, make sure you pay attention to this, because from now on we'll be using this the rest of the time, and it is, I would say, confusing if you're not paying attention and just have to try and jump into it.
This is my 3rd time going over it, and I'm actually like wanting to go over it again.
So I'm going to create a new project. I'm going to use Windows Forms application, the .NET framework. I'm just going to call this one Test Baseball Player. I'll stuff it in my examples. Will that give me a problem? I just brought it down. Let me move it just in case. Or actually, a second, I'll create a new folder in here. Class. Bless you. You guys can put this in your examples folder if you want to, if you're coding along with it. The only reason I'm not is because I already have some of this stuff out there and don't want to cause problems. So create it.
What'd you put as a solution?
Test baseball player.
Same thing?
Yep. So once you create it, you get your form. To add a class to your form, before we were clicking on the solution, Test Baseball Player 101 projects, to add another project to it. Instead, we're going to go just below that where it says Test Baseball Player. You'll right click on that and you go down to the add again. And as you get to that add, you want to go down to class and then click on that class. And you'll see it has a whole bunch of stuff you can add into it. Up top, it should be class. We're going to add a class, a C# class up there. Click on that. Down at the bottom, it has name. And we want to call that baseball players. Trying to find my other window. There we go. So we want to call that baseball player. For class, the file extension is always CS. If you don't type CS in there, yeah, it automatically does it for you. Yeah. So if you don't put a name in here and just, I guess, oh, it was, here, let me cancel this, redo it real quick just to give you an example here. Add class. If I click on class, you see it says class 1 down there, and I add it like that. So you can go ahead and create your class. You'll see the namespace is just the name of the file that we called it, Test Baseball Player. I didn't change my name here, so it shows class 1, but you can go in here if for some reason you forget and add it in there like that, and it should work all right. Well, when we look at our access modifier here, like we had on the other ones, our access modifier shows internal. Internal is kind of like a protected kind of a class. We don't want that, so when we create these, when it says internal, we want to change them to public. And what's public allowed to do?
Be used in other files. Isn't it?
Yeah, outside of this class, it can be used. So that's how we'll start setting up our class. So, get what I need. So for this demo, we're going to create an application named Test Baseball Player that instantiates and displays a baseball player object. The baseball player class, which we're creating now, contains properties that hold a player's name, which is going to be a string value, a jersey number, which is going to be an integer, home runs, an integer, and RBIs as an integer. So, first thing we're going to do is we're going to create attributes and some instance fields. So, attributes or properties, as they're called, they're interchangeable. You'll probably hear property more than attributes. And that's just the data that we're using for these. And then we have instance fields. And each instance field is unique. And an instance field, all it is like a variable. It's just going to hold some data for us. And we're going to end up populating it here in a little bit. So when we do these instance fields, we have to set them up just like we would as a variable. So we got to give it an access modifier. Even though we call this class public, our access modifiers are always going to be, or our instance fields are always going to be private, because we only want to use them in this class here. We don't want to use them in another class or on another screen or anything like that. So we're just going to do a private. And like I said, our jersey number, or our player name, is going to be a string. And these instance fields, you start them with an underscore. And then the variable name that you want to give it. Ours is going to be player name. And then we'll do private. And our jersey number, we said, is going to be an integer.
How did you open the class thing again? I wasn't.
You go up here to whatever you call your class, right click on, or go up to, you're going to show him.
Just name it like baseball player. Yep. You don't even have to use CS, it'll add it at the end.
We got ahead another time.
No, I was just showing Timothy how to bring it back up. Later on in the line we will, but not at the moment. I think most of this gets put in all one class.
Okay, real quick, so we started out with a class instead of like doing our regular stuff. Why?
Because we're going to,
The class is the blueprint for objects.
yeah, so when you create an object or a class, might get rid of that.
How do you know, does it tell you in our, like, if you give our question, like, hey, start out as a class, or like, start out as a class, or how?
Yeah, so when you look at our labs here, these UMLs here tell you this is, that flashcard is a class name here, is what you want to create. This flashcard, this underscore term and underscore definition, these are the instance fields that we're creating now for it. That's what's going to hold the data and get the data for us that we're going to use. Then we do, this is called a constructor, and we'll get more into this as we get along a little bit further. it's like a method that you're going to pass variables through to get your data and set your data at. And these get terms they're technically methods, but they have a name that we'll talk about as we get through it.
Isn't it like accessors and mutators?
Yeah. As we get through it to the accessors get the data, the mutators set the data kind of thing. And we'll talk more about that as we kind of get further into this. So a class is a blueprint of an object. So think of the class as a cookie cutter. So the class is going to be a cookie cutter. An object is an instance of the class. And when I say instance is just when a computer system creates new context based on a pre-existing model or scheme. So that pre-existing model or scheme is going to be these objects and classes that we're going to be using. So the model is said to have been instantiated when we actually use it. So the encapsulated content that results from this instantiation process is referred to as an instance of the model or scheme.
I didn't understand that when you said it, but yeah, I get it.
Yeah. Well, that's why you should have read chapter 12 before we got to this part 2, so you knew some of this, but we'll get through it. It's not going to be that bad. By the time I give you these couple examples, you'll probably understand it a little bit better. So as we work on these instance fields, we're going to continue on. We want an int called home runs. And a private int called RBIs. And so when you declare your classes or name your classes, classes are nouns. They're going to be like a person, a place, or a thing. Not normally a person, but like a description of a person kind of a thing. So when you name your classes, it's going to be some kind of a noun, person, place, or a thing. And so now we have our attributes, which hold the data, the instance fields, which these are here. So now we're going to create some methods and some accessors. So the methods that we create are just behaviors of these objects. So when you see these methods that we create, it's just the behavior that we're going to get out of these or use for them. So methods are behaviors, and then we have accessors. And the accessors put the data out. And mutators, which bring the data in. So these accessors and mutators, the data out and data in, they're get and set methods is what they are, and that's where these methods for behavior come from. So in the real world, when you start working somewhere, more than likely you'll hear them called getters and setters, and that's because of how the wording is. You can see our accessors always start with get, so it's going to get player name, get jersey number, get home run, get RBI. So we'll have 4 accessors. Yeah, Timothy.
Very small question. What is the reason for putting underscores before each variable name?
It identifies it as like an instance field better.
Oh, okay.
What's that? Yeah, I didn't hear.
The why we put underscores at the beginning.
Underscores,
Of
yeah.
the attributes.
Just so you can tell it's an instance field.
Yeah.
As we go along further, we'll start changing some of these up and do them some different ways.
It's not like a naming convention more than actually.
Yeah. So these are accessor methods, and we should all be familiar with methods by now. And so these accessor methods, they get the data for us. So when you get data, it usually just puts it out to the screen. It's something you can see. If you just have a get but no set, it's considered read only, and we'll get more into that as we keep going through these. So we'll create our first accessor method, and we'll call it public. And we want this public because we're going to use these gets in our code later on when we go over to our window and our button click event. And that way it can be used outside of this class, baseball player. Same reason baseball players declared public up here for our class is so we can use it outside of this class. So we can use it more in our code wherever we need it. So we'll do a public, and these accessors, I can't think what the name of it is now. Well, anyhow, what is the word I'm looking for? Access modifier. The access modifier on these are always going to be public. And then our data type, and this is just like setting up a regular method that we've been doing. So our data type here, since we're coding for this player name and it's a string, our accessor method data type has to be a string. And we're going to create our method now called getPlayerName. And you can see it's a method because we got the parentheses behind it. And we're just going to, and you can see IntelliSense is already thinking ahead for us, as we return the player name.
This is just a heads up for IntelliSense, but it's going to try to do it like 3 different ways at different times.
Yeah, and I'll show you a couple different other ways. So next thing we want to do is we want to set up our jersey number. So our jersey number is what kind of data type?
Integer.
Yep, integer. And we'll do get jersey number. It's a method, so we got to put our parentheses behind it. And these, we don't pass any parameters in these. These are just, for the most part, void, because they don't return anything. But because it's in the class, we don't have to tell it void or anything like that. It knows that we don't have to return anything for, or technically not returning anything for these, even though it does show our return for player name over here. We don't have to put it, the data type or anything like that. Or actually we are, but we're not passing parameters is what I'm trying to say. We're not passing any parameters to these. We're just going to get data and return it. And that's our data types that we're returning. Sorry for the confusion on that. So we're going to use this arrow function. And you can do it like this if you want to. It does the same thing. You just don't need the curly brackets and that around it. And I'm going to do it. Yeah, lambda operator is what they call it. Yep. So so it's like an arrow function that we used in JavaScript. So if you used it in JavaScript, you're pretty familiar with it.
So what does it do?
It's just shorthand to where you don't need the curly brackets in the return. It's just saying that handles it all right there with that arrow.
Like you can have the curly brackets, but you don't need it in that case.
Yeah, so like the get player name, we used the brackets and did it like that. Or you can do it, this is kind of like a little bit of a shorthand version of it. You don't have to type the brackets or the return. But
Yeah, if there are curly brackets, would you have to put return?
yes, so I'll do another one with the curly brackets to show you. So our next thing is we're going to get the home runs. So get home runs. And then we need the curly brackets. And then we get the return underscore home runs.
Would you say, so the get jersey number, what was that called?
The lambda operator.
Lambda, L-A.
Yeah. Yep. I think it's LAMBDA or something like that. BA.
And the arrow is the warehouse operator.
Yes.
And that would work the same way, like doing the return thing.
Yep. Works same as using bless you. And then we use the regular version of it, and then we'll do another Lambda one just to kind of show you how we're going to get RBIs in this one. Again, no parameters being passed, and we'll use the Lambda operator again. That returns RBIs. So whatever you're more comfortable using, I would stick with one or the other, but don't interchange them like that. That's not really the way you want to do it. I just did it here as an example. So now that we created our accessor methods, we need to create our mutator methods. And this is going to set our values that we need. So again, these are going to be public because we need to use them in other parts of our code outside of this class, and we have to have public on for it to do that. So we will do it with set, and you can see the mutators use set, the accessors use get, and that's why in the real world a lot of times you'll hear people say getters and setters. Tomorrow I'll bring you some Java code in that I did in the past and kind of show you how they set it up in Java. Eventually we'll kind of get, by the end of tomorrow, kind of setting it up the way they do in Java if you want to do it a little bit quicker and more comment. But most of the time in Java you'll have one file that does nothing but set getters and setters the whole time. So now we get the player name, now we got to set the player name. And this one we will pass in parameters on these. We're going to, thank you, I missed it. These will be void because we're not really returning anything, we're just setting it in these. The getters actually return something for us. They put it out on the screen. The setters bring it in, hold the data. The setter or the accessors actually bring it out and use the data for us. So string player name. And these are, like I said, these are just parameters. You can name them anything you want. You usually want to keep them pretty close to what you're trying to work with. It is a method, so we got to have our squiggly brackets again.
Trick you can do is that when you're done writing the method, you can just do shift tab and make the curly brackets for you.
And it'll do what?
It'll make the curly brackets for you.
Do the curly brackets for you.
Yep.
Thank you. So when you do these mutator methods, we'll take our instance fields and we set them to our variable that we're bringing in through our parameter. So we'll do player name equals, and IntelliSense is pretty good about a lot of this stuff. Player name, and that sets up our player name. Then we'll do another one. we're going to set our jersey number. Of course, our jersey number is an integer. And another shorthand way we can do this, instead of putting the squiggly brackets on it, is we can use that lambda operator again and just do underscore jersey number equals jersey number. So if you want to do a little bit more shorthand, you can do it shorthand again like that. We need to get our home run or set our home runs. Again, that's an integer because we declared it up here at our instance fields as an integer. And all these are our variables here that we're setting, just like we've been doing before. But because it's an instance field, we put that little underscore in front of it. But we still have to give it an access modifier and a data type. Down here we call it, just like we do parameters, they have to match up with what you set up top in your instance fields. So, home runs. And then finally, I think that's what I called it, set RBIs. And then I'll do shorthanded again, just to show you. Like I said, you're better off picking one way or the other and not interchanging them. It's just not really good coding practice to do it like that. So now that we have our class all set up,
Underneath the home runs, and I don't know why.
what's it say when you hover over it?
Like, does it exist or something like that?
Did you name it something different than what it is?
I fixed it.
Did it, what was it?
You had a capital R instead of
Yeah, yep.
I did it.
So now we have our cookie cutter set up. Our cookie is inside of it with all of our data information that we're going to use. So now we can go back over to our form.
Oh boy.
Yeah. And we'll actually code some of this out and see how it works.
Can you scroll back down all the way?
Yeah, one more question. So
Yep.
for the is it whatever it's called? What's it called again? Lambda?
What's up?
Grab back assumption.
Oh, yeah, he hasn't done it. I literally just have a button.
The lambdas,
Yeah.
it's just a shorthand version kind of to code it out. It's a newer thing that they use that they introduced. It's up to you if you want to use it or not. It just, like I said, it just replaces the curly brackets.
Right there.
Yeah.
That seems like a way more confusing way to do it. Is that really?
And that's whatever you're more comfortable with. As I've always done it, and Java doesn't have this lambda operator thing for it. So as I've always done it, it's always been with the curly brackets like that and setting it up. To me, I don't know, it looks a little bit better that way. Especially when you write methods forever, and that's kind of how you write methods for the most part like that. It just, for me, it's always been habit to use the curly brackets. So we'll go back to our form, and we're going to add a few things onto our form now. So all I'm really going to do here is just add a button. My button. I call it create player. Give it a name of BTN create player. And then I'll put a label down here. And my label I'm just going to call LBL result.
Timeless classic.
Yeah. Can't go wrong with that very often. Get rid of my text. I don't want anything to show up there. So everybody in a good spot with that?
Yeah. What'd you call the label? Yeah, what happened?
I just call it result. We'll double click on our button to get it wired up and ready to code. So now in our button click event, we're going to set up our baseball player object. So we'll do baseball player. And we're just going to call it player. That's right. Should I put an A at the end? P-L-A-Y-A? Playa. And you can call it whatever you want. This here is just another variable. So we could call it playa if we wanted to. We could call it whatever we want. This baseball player in front, since it is an access modifier technically, or actually it's not an access modifier, I'm sorry, it's a data type is what it is. And this data type is technically what they call a reference type. And the reference type is just the name of the class that you created. So we have to use baseball player because that's what our class is called over here. Baseball player.
Mr. G, would it be wrong to say that like classes and objects are kind of like customizable variables in a way? It's ways to store data that we can design.
Yeah, that we can set up however we want to. Yeah. So, and again, we'll do the new keyword. And like I've said before with the arrays and stuff, when we see that new, as soon as you see new, you know you're creating an object at this point. So our object is going to be baseball player. And you put the parentheses behind it. And the reason we put the parentheses behind it is because we're calling a method.
It's our constructor.
Yeah, but this method is called a constructor. And it's constructing our object for us. And that's why they call it a constructor. So if we go back to our class, technically we would have a constructor down here.
But we get it for free.
Yeah, so you don't, the reason it's here, we don't see it, but it's here. It's, as Matt said, we get it for free kind of a thing. It's already set up for us when we create that baseball player class, and it just looks like
that.
Yeah, did it show it?
Yeah, it popped up for like a split second.
So it looks like this. So that is what we just kind of coded out, is this class creates this constructor for us. This is considered a constructor. and it's constructing our object for us. And this is the data we want to use from our object, is all this here. And as we go further, we're going to overload this method inside this the constructor. We're going to overload the constructor, make it to hold the data that we want it to, rather than just a generic kind of a holder. So when we do this, baseball player equals new baseball player, we're instantiating the object at this point. That's what's considered instantiating the object. It means that we're going to use a template that's already been created and do something with it. So now to set values for this, what we do is we do player, I guess playa, since that's what we called it here. So you use your variable name that you created, dot, and we say set player, I guess player, since technically that's what we call it for set player name. And again, that set player name, if we look, the set player name is a method, and it's expecting a string called player name. So we do set player name, the player name, I'll put Paul Goldschmidt. As the player name.
If we wanted to have like multiple variables, this is something I kind of just want to double check on. We would like to do like, you know, like baseball player equals whatever, and then we'd have like baseball player 2 under it.
Yeah, I'll kind of show an example of that, how we do another one. So our next thing we need is the jersey number. We gotta set the jersey number. Of course, his number isn't 1, it's 46. And you can see if we try and put a string in here, when we say we told it was going to be an int, so now it's mad because it says that cannot convert a string to an int, because when we set it over here in our class, we set jersey number to be an integer, so it's expecting an integer, just like anytime we passed in parameters and that, using those methods. Same thing, we're still using methods here, we're still passing parameters.
Can you do me a favor?
Yep.
Can you scroll into the top real quick?
Oh. Thank you.
So technically I could comment this out, this constructor, I could comment that out and it'd still work, because like I said, we get a constructor here for free, so we don't actually have to code it. But I would get in the habit of always coding this out.
Because if you overload, you have to do it.
What's that?
If you overload, you have to do that.
Yeah. So I know when I did Java all the time, it was just habit. That's the first thing you do is create your constructor. And then as we go further on, we're going to overload this constructor with some different parameters and that. And so it's just good to get in the habit of always starting out with your constructor. So of course, like I said, set jersey number is expecting a So again, like I said, we had a string for set jersey number. It didn't like it because when we set it up in the class, we told it we wanted an int for the jersey number. Our set parameter was an integer, and that's what it's expecting for our instance field jersey number to be the same as our parameter we're passing in, jersey number being an int, so they should match. It should be happy. Next thing we have is set home runs. Home runs again is an integer, and you can see down here it's telling us Void baseball player dot set home runs. It's expecting an integer for the home runs. So we'll put 32 in there, semicolon. And then finally set RBIs. You can see our drop down here gives us examples of what there is. You can always click on those if you want to save some time with typing it out. RBIs we'll put at 100.
You're just doing random numbers, right?
Yeah, right now I am.
RBIS.
RBIS. In baseball, it's runs batted in. So that's how many times they got a hit and somebody crossed the plate when they got a hit.
So would that be in like the question, like the numbers that you have, that you gotta push, you know what I mean? Like it gives you like a chart or like an example, and these numbers will be in there and you have to plug these in?
In our labs, you mean?
Yeah.
Our labs, I don't think show numbers like that.
Right. Do we have to plug in or anything?
Yeah, more than likely you'll have to enter them in somehow. So like I know on the store inventory you create, I don't know how many different actual items with the UPC, a name UPC, a price, a distributor, units per case, that kind of stuff.
Yeah.
You just put all that in yourself.
You just do whatever, it doesn't matter.
Yeah, you just hard code it in at the beginning in an array. Eventually, because we are getting ready to start talking to databases with this stuff, we don't want to use an array as much as we used to. We want to start using a list a lot more. I'll show a couple with arrays, and then at the end I'll show.
Isn't there a raised list too?
We are going to, not an array list, but we're going to use a list. But it works almost the same way as an array.
Right.
One of the differences is you don't have to tell it a size. It automatically resizes as needed and stuff like that.
That's helpful.
And so when you're returning stuff from a database, you don't know how much is going to come back. I mean, you can have hundreds and hundreds of rows come back from a database, so the list can handle them all. You set a list for a size of 3, and you bring 100, it will keep doubling that 3 to a 6, that 6 to a 12, until it's large enough to handle everything that returns from a database. So that's why you want to kind of get more in the habit of using lists. In the real world, you use a list a lot more than you will array when you start working with database stuff and that.
So every group box is like one class.
No, this is all going to be one class. You can call it like store inventory if you want to for your class.
So it looks like multiple things at once.
So you'll have like a name, a UPC symbol, a store price, a cost per case price, a units per case price, a distributor price, and a access key prices, or an access key is the main things you're going to end up storing. So anything down in this add new item part here, you're going to end up being part of your class, in your class or your object. It is a lot, and this is, to me, was a fun one because it's more real world kind of an application you would see than some of these other ones like the egg counting one and stuff like that. Yeah, Henry.
Does it matter like what order to make our custom class in? Like, do you normally design the form first, or does it matter?
It doesn't really matter. The only time it really is going to matter is when we start overloading this constructor. Then it has to follow a certain pattern of being put in because it's expecting the parameters passed in a certain way.
Okay, and when we're working with the random number generator, that's basically in setting an object, right? Just built in.
Yeah, it's a class technically. That random number, random is a class, and then you use that random number generator out of that class, kind of a thing. Yep. So like I could set my RBIs up here if I wanted to. It won't make a difference because we don't have a constructor set up to accept parameters in a certain way or anything like that. So we can put it in any way we want. So then if we want to print this out, then what we'll do is we'll do our label result equals, and I'm going to do string interpolation here just because it's easier. And eventually, as we've been coding some of these out, and you're printing them out to the screen, you'll see that .to string pop up to convert some things to a string. Eventually, we're going to override that toString method and make it our own method to have it print out what we want it to print out and say. But for now, we'll just use a string interpolation, and we'll say player name. And to get it to populate, we got to do playa, since that's what we called our variable up there. That's what our object name is, that playa. So we got to access this object by using its name, playa. And now that we want data to come out and show on the screen, we use these get methods. So now we got to get playa player name. Playa.getPlayerName, yep. The playa is what we named our object up here. And so all this data that we created, this playa.setPlayerName, that's all getting stored in our class now. So this player name, this jersey number, home runs, and RBIs, they're all getting set by these set methods we created down here. So when we look back here and we got playa, that's our object we created. This is a variable, an identifier. We can name it anything we want. A couple people said playa, so I just screwed around and put player in there instead of player. But you can call it anything you want. It's just another identifier like creating a variable. This baseball player here behind it is a data type, but they call it a reference data type. And that's because we're referencing this class for our object. And so the new keyword here says we're going to instantiate a new object. We're going to use a template, which is our class, and our object in the class to create a new object called baseball player here. So then this playa dot is using the object we created right above it, the line above, and then we're using our methods that we created in our class to set these values into it. So the set player name, we go look here. Here's our method we called set player name. It's looking for a string player name. Here's our string with the player's name in it. And so that's what it's going to accept. And as you start creating some of these classes and they get bigger and bigger, if you hold the control key down and go over the set values or the set methods here and click on it, it will take you back to your class, to that set method that you created. So that way you can, as these get bigger and bigger, and especially if you work somewhere and you're maintaining legacy code and you have all this stuff already done for you and you're trying to figure out how they set up set player name, you can hit the control key, go click on that set player name in your form, and then it'll take you back to the class and show you how they created it all. Just like I've been doing with this initialize component. If you click on that, it takes you to the setup, the method for initialize component. You can see what else is in it. So if you want to see what's in the class, like set RBIs, we can click on that, and it takes us to our set RBIs method that we created. And then set RBIs, as we just saw, it takes an integer for our set RBIs method. That 100 there is an integer. Like I said, if we try and make it a string, yeah, it's not happy because we told we wanted an integer, but we're trying to pass a string into it. And it says down there that CS1503 argument 1 cannot convert string to an int. So we know we put the wrong data type in there, so we got to get rid of that. Set jersey numbers again. We got that as an integer. It's passing in an integer. Set home runs is an integer, and we're passing it in as an integer.
Hey, Mr. G.
Yep.
You know in the set methods, I come a time where we're actually using those parameter names, like player name, like as fast as a parameter, or is that just setting the value?
It's more for just using it to set the values. We will do some math and stuff in these at times, and then you'll use that variable name to help set, just like we did a method and we did some addings and methods and stuff like that. It's the same way. It's just passing that number in. So our RBIs we set at 100 here. Well, it's passing it into the set home runs method, or RBIs, I should say. The 100 for RBIs, it's passing in that RBI. So this variable now is holding the number 100 in it because,
Okay.
yeah, that's what we're passing back. That's our argument that
The
we're.
get methods is just kind of a read-only type of thing?
Yes, that just displays something for us for the most part. And there will be times where we won't have set methods with these get methods, and that's considered read-only at that point because we're not changing anything. We're just showing something. We're not going to change it. It just displays, so we can't change it. So it's read-only at that point. So let's finish getting this to print out real quick. And then we'll take a break, and then I'll show you how to put a second one in there. So you want get player name, and then I'm going to do a line break afterwards. And then player jersey number. Guess I'll do lowercase just to keep it all. Equal. And again, to access that, we got to call our object we created called playa. And now we want to display it, so we use the get method. Get jersey number, and you can see our little drop down here. It gives us some hints to use already. The star means IntelliCode suggesting it based on the context of what we've coded out already. It's the more likely one to use. So if you want to save some typing, you can just click on that and it'll give our method. And like I said before, the one student was trying to let IntelliSense type everything for him. So if he typed in something wrong, so if he typed in like get jersey num, and it had an error and it didn't have the drop down, he had no clue what was going on because he was letting IntelliSense do it all for him instead of trying to understand what was actually going on. So IntelliSense is nice, but make sure you know what it's doing while it's doing all this stuff. So I want another line break here. And the plus is just concatenated. I'm just doing this so I can make it a little more clean instead of going completely across my screen for 1,000 rows. And you can see IntelliSense is trying to tell me something I don't want, so you kind of got to watch that. If you just say get 8, oh yeah, that's right, we don't want that. The hash is just a way of storing some stuff, but we don't even mess with it in here. You'll probably see it out in the real world. I know I did in the Java world, but. And then finally, we're going to display access it. We got to call our object we created called playa. We're going to get our BIs using the method. And that should be that. So now if I run this, it should display player name is our player name here we entered. Jersey number will be our jersey number we entered that we passed through. get home runs will be the home runs that we entered here, and the RBI should be that RBIs we entered. So let's run this real quick, and then I'll come back to the code if somebody's still typing it out. So there's our window. Click on Create Player. And there's our information we just put in and passed through and everything. Player name Paul Goldschmidt, jersey number 46, home runs 32, runs batted in 100. And that's exactly what in here. Yeah, Paul.
For whatever reason, that line breaks aren't working properly.
You have the ends.
Yeah, the slash n inside the parentheses.
The parentheses.
Right after the slash kind of slash it, you're doing one slash. Oh, oops, forward slash. There we go. My bad. I think it was that because I had the problem to it first.
Yeah.
So, Mr. G,
Yep.
instead of hard coding the data in the object, the set player name, the set everything,
Yep.
just like variables in there, make it like more dynamic, where the user into
Yeah, and I will show an example how to enter data in eventually and use that instead. But what we could do is we could put text boxes up here and just get the values from the text boxes and put them in there if we want to.
Okay, you can put it.
And we will. I will show you that on a coming up example on how to do that. Yes. Give me 1 second. I'll come over there. Let me pause this real quick. We'll go ahead and take a look at how to display another one out. Ryan, shut the game off. Thank you. I saw your Discord message, Matt. You trying to give him the MVP award?
I was like, oh, I can name it whatever I want, huh?
So now to add a second one, what we do is we can just do, we call our class again. And we'll call it Playa 2. And we do a new baseball player. So we create a new object called baseball player and put it in our variable Playa 2 that we just created. And then we do it just like we did the first one. But now we have to reference Playa 2. And again, it's a method, so we need parentheses. Set player names looking for a string, so we'll do Jordan Walker. Set RBIs since it's in that order, and it's kind of pre-filling it in for us to save a few seconds. So we'll set his RBIs at, say, 75. Set jersey number, and that's looking for an integer, so we'll put it at 16. And set his home runs, and we'll set his home runs at 22.
Does Mike Trump still play?
He's still playing if he's not hurt. Yeah, he's hurt all the time.
Or the best ever to do it.
That's what they say. So that's how you create a second one. You just use the same class. We call the same object. We instantiate the same object. We just give it a different identifier name, a different variable name. And you can call them whatever you want it. You could have called this P. Goldschmidt or P. Walker or J. Walker, anything like that. You could call it whatever you want. Like I said, yeah, it's just a identifier variable name like we've been using all along. The only difference is we put this reference type in front of it, which is the name of the class that we're using. So now to get this to print out, what we got to do, and I'll do label result.
Plus or minus, or plus equal.
Yep, and I'm going to put some spaces in between here to get it to space out a little bit between each one. And then I'm just going to copy this from up here since it's going to be pretty much the same thing instead of typing all that out.
Oh, shit.
Watch the language. And so now all we do is change our object name there. Why is that unhappy? What did I forget up here?
What's going on?
Oh, and forgot my dot text.
Yeah, I was.
So when you get those errors like I just got there, it's always nice to hover over them, and usually you can kind of get an idea what your error is by their message. You can click on the show potential fixes and see if they have a fix that you might be able to use. I'll apply their suggestion. And if not, you can always Google it or ChatGPT and see if they can help you figure out some of the errors. So now if I run this, gotta close my other window. So now if I run this, I create my player, and there I have Paul Goldschmidt, and now I have Jordan Walker in there.
It's not showing anything on mine.
Did you do plus equal? Oh, I see.
All right, hang on, I'll come and take a look. That's the end of that one. That kind of just shows you how to set up a class, how to set up an object, how to get your mutators and accessors set up, create your instance fields, look at the constructor. So now we'll do another one. Give me a second to get it set up. So we've got test classified add for our project. Scroll down. Go to add, scroll down to class. And we will name our class classified add. Go ahead and add it. And again, this automatically sets it to internal. First thing we want to do is change that to public. That way it can be used throughout other classes wherever we should need it. And then it said, what did it say? We need fields for category, number of words, and a price. So we'll start out with our category. So string, or I'm sorry, private string category. These are instance fields again.
I was just about to yell out like, what are these called?
Instance fields. All they are is variables that we're going to be using for the most part. So just think of what variables we need as this thing says here. We need fields, and they're instance fields for category, a number of words, and a price. So category, we'll do a private
I'm assuming int.
int. Yeah, int num words, and I need my underscore in front of it. Num words, and then we'll do a private decimal and call it price. So I think that's all 3 fields that it asked for. Category, a number of words, and a price. Include properties that contain get and set accessors for the category and number of words, but only a get accessor for the price. So we'll set up properties in this one compared to how we did it last time. So when we set up properties, we can put the getters and setters together in them. That last one we did, we created a method for our getters and a method for our setters. To me, in the Java world, this is how you'll see it more often than not. But this way, we're going to put everything in a property and do our getters and setters in the property. So we're going to do public. And again, why is it public?
So it can be accessed.
Yep, so it can be accessed throughout. So public string, and you can see we called it a string, and then category. And our properties, they always start with a capital letter. You'll use Pascal casing on them. Now, this isn't going to be a method, so we'll just put our squiggly lines, brackets behind it. And then we'll set up a get. And we're going to do a little bit different this time, so we'll do get. And then put the squigglies, and then we're going to return category. Then we'll set the category. And it's going to equal value. So whatever value gets put in, that's what it's going to equal, is the value that we're going to put into it. There is a shorthand method of doing this. So instead of doing all the get and set like that, we can do get and use that lambda operator again. And set category. And set category value. A little bit cleaner that way.
It also takes 2 lines instead of
Yeah, instead of 8 or whatever it is.
Technically, you don't need to space out the curly brackets if you just have them on the same line as get and set.
Yes, you can put them on the same line. That the lambda operator pretty much removes the curly brackets and that return keyword. And then you can just set it there like that.
So what does the get function do?
The
Get and set,
The get, when we print it out to the screen or need data to show up on our screen, or for us, we use the get. The set takes data in and sets the data, so when we get it, we can use it. So just like on this one,
so it's just to be used for later.
we're setting it up to use it for later, yes.
So why are you returning category?
Because we're eventually going to use category and print it out to the screen.
There's nothing that equals category or anything.
Well, we don't need anything to equal category, because whatever category holds, we're just going to show it to the screen. We're not going to change it. We're not going to manipulate it. The sets we manipulate, we can change the values of. The values of sets will change. The get values don't change. The get values are just getting the data and displaying it.
That's a lot to take in.
What's that?
That's a lot to take in. You just said.
There's a lot going on here, yeah. That's why you have 10 days to work on this, and we're going to take our time and go over this and make sure we answer any questions and that.
Let me get this.
So now that we set up our property, and then I'll do this just to this is our properties. are used in C# to set and get data. So pretty much like we did on the other one, it's just a little bit more condensed than having to write out a get method and a set method. We just put it all in this property, and we can access it through the property. So now we need to create one for num words. We declare num words up here as an int. So we do num words. And it's always mad because we're not indexer, doesn't have the accessor in it, so it needs something in there to make it happy. So we'll do what's that? Not on the properties, only when we declare these instant fields up here. That's where you have that underscore at. And then we're putting values into these underscore, the instance fields in here, and that's why we have them down in here. Because this is either getting that value that we're going to store in there, or it's going to set it and somehow change it. So we can do the lambda again to save some time. Num words, and you can see it's already trying to set my mutator there. Num words value. And then I think it says price is read only.
Yeah.
So we'll do public decimal price. Oh, IntelliSense is good sometimes. So if it's read only, what's
Only a getter.
yeah, we only need a getter if it's read only. So we do get, and you can see as soon as we start putting that get in there, it's our accessor, so then it gets rid of that red line. Under price, so we could either do it like that.
Why do we need underscores?
Why do we need what?
Underscores, just to indicate it like an instance thing, and not just
Yeah, to show that it's an instance field, and that's what we're using as an instance field. Eventually, we'll set it up to where we don't need them like that as much. I'll do my get like we've been doing them just to stay consistent. And actually, yeah, so I'll do my get like that. I think it says to calculate something on here. Let's see. But only a get accessor for the price. The price is calculated at 9 cents per word. So we can actually do our calculation in here for price. So we'll take our variable num words, multiply that by 0.099 cents a word. And to show it's a decimal, we need that M behind it. You think it'd be something better like a D or that instead of an M, but so now our price we calculate out here. We're just going to splat that out to the screen with that get. But because of that, we're not using this variable price anymore, so we can actually get rid of that up there. Just comment it out, or you can get rid of it. We created a property, a read-only property called price that's going to calculate the price that it's going to cost by taking the number of words entered and multiplying it by 9 cents. So now we can go create our form.
Oh boy.
Yeah. Hey, this is the easiest part of all of it.
Finally, something I'm confident in.
So wait, what does it mean by like read only?
Read only means nothing's going to change on it. So all these other ones where we have set with them, data's going to change in them. When it's only a get, nothing will change. It's just going to print it out for us. It's just going to bring it back to the screen with some kind of value for us.
So if we're calling the class for like numbers, oh wait. So if we're calling the class, basically that's where we can use all these methods in the class.
When we instantiate a class, yep, when we declare a new object, when we instantiate the object, we're going to get these values and set these values from that. Just like we did on this first one, we create this object called baseball player. We go instantiate a new object called baseball player, assign it to our identifier variable that we called. We use the object we created, this player 2, because we created a variable. We're saying it's a new object, put that object into player 2, and then we use those sets to manipulate the data, to change the data. We're adding new values into it. That get, when we print it out, the get down here when we print it out just takes what was set and prints it out to the screen. So that get will never change values or anything. The get just prints out what value the set put in there or what we put in there. So that should be it for our class. We've got our form. We'll put a button on our form. Yeah, Paul.
So like with that public decimal price, how come I tried to do like the get with the brackets and it wouldn't let me do num_words times 0.09 because it said not all code words or not all code paths return a value, and then it said something like cannot assign increment things. I don't even know, but then I use lambda and it works just fine. How come?
So let's take a look at it and see. And we want words. Times point oh nine.
Yeah, that's what it was telling me.
So
Do you have the M at the end?
I do need the M, but
I mean, I had that.
now we have to return something,
Right.
and we want to return,
What did we return price?
I think it is, that's still not happy, multiplies to specific decimal values, overflow exception, only assignment call, increment, decrement, await, new object expression can use as a statement. Return price. So we're saying underscore equals num_words 09.
Let me check the OG version that I did, just because like I kind of remember something like this happening, but I can't remember why.
Mine's not having like that.
You have to assign something to it because we were just using the property of it. We didn't really need it to return like that, but because we did it with the brackets and the return, we have to use the price up here, the instance field, assign it that calculation, and then return that.
So if it's going to be read only, is it just better to do it shorthand with lambda then? Instead of
saves a little bit of time like that. Yeah, you don't have to worry about all the extra stuff.
That extra memory stuff too.
Alright, so I'll count this back out. So go back to our form. Put a label on here for our results. Don't want any text. Oops. LBL result. Name my text box. TN create ads. Ads. So now I got a form completed. We should have our class completed. And so we'll go ahead and double click on our button. Get our button click wired up, ready to go. So now what we can do is we can set it as an array if we want to. Since we're going to have two classified ads, instead of doing it like we did on that last one, where we did player 1 and player 2. Now we can set up an array if we want to. And this is called dimensioning an array with two classified ads. And just kind of like what we've been doing with arrays all along. So classified add. It's gonna be, this is our reference type here for our class. And we're just going to call it classified ads. Equals new classified ad. And we said we want two of them, so of course we size our array. We put the 2 in there, so now we're saying the object array that we're using has 2 objects in it. And now this is going to create if we did it like this, that's just instantiating our object. That would only be creating one object at a time like we did on the last one. Now that we have this array up here, we can do 2 of them. So I will just say 1 add. We're not going to use that because we're using our array. So we're going to use a for loop to walk through this array like we've been doing all this time. So we'll do a for loop. course, I equals 0. We are going to use classified adds.length since classified adds is our identifier for our array. Of course, we use the length when we walk through an array, and then we'll increment it. So now what we're going to do is take our classified add that we created, give it the value sub index of I, and make a new classified add. So here now we're instantiating the object classified add, but we're adding it to the index. And of course we know our index is 2 because that's what size our length is on our array. Yeah.
I'm getting an error on my classified add. Is a namespace, but it's used like
Go back to your class. Scroll up.
Did I miss some part?
Looks like.
Check your other people.
No, your class name.
I think it has an extra D in it.
Well, no, not there. The actual class name. Scroll up.
Oh, it's class 1.
Yeah.
Oh.
Yep, you didn't rename it. So go whatever. Go to your give me your form. Go back to the code and your classified there. Yeah. And I would take that extra. No, you don't want class there. Well, you could have did class 1, but you don't want it that way because that's messy and that's not the way you should do it.
Yeah.
So I would take the extra D out of the classified add, and then copy that classified add, but not the bracket. Yep. And then go into your, and then paste it there. That should be good. So go back into the code. Should be happy. You just need to change your new classified add. Get rid of the D on there. Yep. So now you should be happy. So now that we have our for loop, we're going to loop through and create a new classified add each time we loop through. And of course, we have 2 because we know we set the size of our array to 2. And so now to set the values for that, what we would do is classified adds, and again it's going to be subindex 0 because it's the first one we are working with. Dot. And now instead of set price or get price, all we're going to do is call our property here. And our property, again, we set it as category. We put both the setters and getters in here. So all we have to do is category. And then we're going to assign it a value called used Toyota. And this is the set block, putting data into our
Object.
Yep. And the reason I know it's a set block is because we have that equal sign. That equal sign is assigning that value to it, which is manipulating the code, setting the code in that. Set block is because of the equal sign. So we know we have our property called category in our classified add class. Our object category, or I should say our classified add object, has a property called category in it. This category is both getting values and setting values. And you can see the equal sign for the equal value here. And that's just what we did. We assigned that value there by this equal sign and putting use Toyota there.
Can you go back down to your class and scroll on down?
Yep. You good on that? So the set value, we're setting the value in our form in that button click event because we're using our property category. And if you want to see, you can hold that control button down and click on category, and it takes you to that property category, and you can see the get and set methods inside there. Like I said, we know we're doing the set block because of that equal sign, and we're setting a value to it. That value is whatever we put over there on the right hand side of the equal sign. So the value we're putting in there, use Toyota. We go look at it again. It says it needs a string as the data type that returns. We're declaring it as a string up here. And so if we try and put a number in here, what's going to happen? It's not going to be happy because it's saying we can't convert an int into a string because we declared that we want this category to be a string. Put it back to a string, now it's happy. So after that, we'll do classified adds again. Substring 0 still because we're still on our first classified add. Just like the arrays that we've been working with and everything, this is our index that we're working with. So the very first index in array starts at 0. So this is our first one. Of course, we want number of words. And we'll just say number of words is 50. And because our price is read only, we don't set a price. We don't have
a set.
Yeah, we have no set value for our price, so we can't change our price in that. That's why it's read only. We can't go in and change our price property because it's read only. It has no set method in it to set a value for it. Does that make sense?
Yes.
I see Jamisha kind of looking.
Do we just get it here then? Or?
No,
That's
I
right.
understand.
Okay.
I just don't understand how we gonna get it to the.
We'll get there. So now that we got our first one, we'll create our second classified add. And again, we're using an array. The second index in the classified add is 1. We got the category again. We're setting our category value, and we'll say used Honda. We're just going to do square bracket 1 again because this is our second value we need into our object. It's going to be numwords again, and we'll say numwords is 40 this time. So now we got our 2 of our fields set, our property set in our object. We have the category set, we got the numword set. Well, the price is read only, so we don't mess with that. So now if we want to display this, we'll do label result dot text equals we'll say string interpolation. The anybody know what would go here if we want to show what the category is for the first one?
Would be classified ad.
Classified as index zero.
Yep.
Yep.
Index is 0 to get that first index out of there. Now we need category. Category to show the value that's being held in that first category. And I'm just going to concatenate this again just to keep it easily readable. Here we want the number of words.
Can you press that there? Oh, not taking that tonight as well.
Does it?
Yes.
What happened?
If you're typing out the word, it's also you press enter.
So Jamisha asked how we get that price out to the screen. Well, it's read only, so all we have to do is access it like we have been.
Don't forget your substring modifier to make it money. Can you do that here?
Yep. So we'll do classified ads because that's our object we're accessing. Substring or index of 0. And our property is called price, so we do dot price. We want it to show as money, so we can put the :C there. And then, since that price is read only, it gets that value that we have set up, which takes num words times 9 cents. What do we have? 50 words. So 9 times 50 should be $4.50.
Yep.
So let's run this. I gotta do my drop down and get the right one. So we'll run this and it should show us the used Toyota ad has 50 words and costs $4.50. Everybody getting that?
Yep.
Everybody understand how we got it?
Yep.
That's the more important question.
Not really, because we're using them right now.
Because what?
Not really, because we're using it right now. I get lost on substrings, so I don't really know how to use it.
Well, it just, you gotta consider, all we're doing is looping through an array. This I sets the value for our first index, so that would be 0 to start out with. We're getting our first one like normal. And we're just creating a new classified ad, and because it's the first one, we give it the value as the index is 0. And it gets set by going through this loop. Because this I here is set to 0, this first classified ad, as we loop through, this I gets changed to 0. And that's why we're accessing 0. Comes through a second time, this I increments, this I now turns into a 1. And this I in here turns into a 1. So then that's we get our second one. If we want to, we could loop through this. If we set our classified ads to 200, this will loop through 200 times and set us 200 classified ads.
Yeah, one of the losses is classified ad.
This one here,
No, like on
the for loop.
not the parameters, but like down below, right there.
So we're just saying, take our classified ad object that we created. This is where we're creating a classified object. Not actually creating the object, we just set the array up, give it an identifier called classified ads, and that's what we're using down here. This is what we want to populate, is this classified ads. So we're taking this array, classified ads, putting it down here in our loop, and we're setting our index at I for right now. And because we haven't initialized it or anything yet, we're using our for loop to set our indexes on it. So our index will be 0 the first time, and when we do, we create a new object classified ads in this index 0.
Because it also.
So when we do that, then we can use classified add 0 there and set our property dot category for that index of 0. Does that make sense?
Yeah. The same namespace, you don't have to.
Why would
It's
two be
basically
up
like
there
how
from
React
new classified, and one is supposed to technically be two indexes already?
Repeat that again.
Why would two be inside those brackets and not one? Since we're talking about indexes.
We're saying we want our size of array to have 2 pieces of data in it, 2 indexes in it.
I thought we.
And an index starts at 0. Yeah, index starts at 0, so that's why we set the 0s and 1s down here. We still have 2 objects in there. That's what we're telling it. We want 2 objects. And so we're saying these are the 2 objects we're putting in there. But to access the indexes out of an array, we start with 0 to get that first set of data in it.
Okay, so we only go based off of that when we actually trying to get the data out of the array, not when we telling the program how much we want in the array.
Well, we're telling it we want 2 pieces of data in there, 2 objects in our array, right? And that's how we've been sizing arrays the whole time, right? When we
Yeah,
tell
like
arrays.
string, new string brackets, new string 5.
Yeah. So we tell it we want 5 strings in there. Here we're telling it we want 5 classified add objects in, or 2 classified add objects in it.
Okay.
There's the first classified add object. There's the second one. And anytime we access an index in our array, we start at 0. So this is getting that first object we created out of it. This is getting the second object we created out of it.
Yeah,
If we want,
because I put 1 up there and it said it was out of bounds.
Yeah.
So I was like, oh, okay, it gotta be.
so if we want 200 objects, we could put 200 objects in there and run through it and set them all, and it would make us
What
200.
happen if we don't set all 200?
And then it might give us an error saying that we don't have enough set. So let's set it at 3 and see what happens. And it looks like it works with 3 because it can take 3, and if we put a third one in here, it'll be all right. But if we put a fourth one, it'll say it went over
The length.
the array bounds, out of bounds for the index. And this is why we're eventually going to stop using arrays and start using lists, so we don't have to worry about telling it what size or dealing with any kind of a size. The list will dynamically increase in size as needed as it grows.
Especially with an initializer.
Yeah.
It says my index was outside of the array.
Well, this is an array that you can add to.
Good. There's that.
It's better usage of space if you have an array,
So you're saying
but if you don't know how.
you
big
only want your array to hold 1 object in it. And so now you got 2 objects in it, so you're over the limit that you told it to. Now if you run it, it should work, because you're saying put 2 objects in there. You've got 2 objects, that 0 and 1. That 0 is 1 object, the 1 is 1 object.
Wait, I thought it would count. Since it was 1, it would count 0 as 1 object and then 1.
No, you're telling how many objects you want to put in there. So you're saying only put 1 object in there. Now you say put 2 objects in there. So to access those objects like we have in arrays, the first index is always 0, that's the first object. The second index is 1, that's your second object. Does that make sense? Yeah. So that all goes back to an array. It's not necessarily to do with the class or the object, that's just more of accessing indexes out of an array. All right. Everybody good with that?
That guy.
Liam asked, where are we creating this object, or how is this object being done? Well, this object's being done by this classified add here. So this new keyword here is saying we're getting ready to create a new object. We're creating an object. So when you see this new keyword, right after that, that's the object we're creating. And that object is over here in our or in our class. And remember I said we get that free one? We get that free one that it gives us right there. That is the object. And that's why I say get in the habit of typing this in each time. So this is our constructor. This creates our objects. So that constructor creates our objects. We don't have to type this out all the time. It's there. It's kind of hidden in the background. When we create this class and everything, it sits in the background. It's there, but we don't see it. That's why you should get in the habit of typing this in every time. When you create a class, your constructor is going to have the same name as your class.
I tried to before we had did anything on the Form 1 CS, and it was giving me squiggly lines.
Did you have the parentheses and the curly brackets?
Probably didn't have a parentheses.
And then no semicolon or anything after it. So when Liam asked, where's our object at? This is our object. This creates our object. This public classified add parenthesis curly brackets, the constructor, this creates our object. And this object that we created holds this data inside of it. It's like a template. So we're creating a template called classified ads that takes a category and num words that we can put data into. This private decimal price is read-only, so we can't add anything into it. We can only pull the value out of it, whatever that value is. The value we give it is that num words times 9 cents. So when we go back to our code, anytime you see this new keyword, you see that new word, that means we're getting ready to create a new object. And that object is that classified add with the parentheses behind it, which is our constructor that we make in our class. Does that make sense?
Sorta. I'm getting there. I'm trying to like understand like the energy with all this.
Understand what? The synergy, how it all hooks together and works.
Yeah.
And that's why I think where a lot of people get confused. And that's why I'm trying to take the time to keep showing that now instead of like our methods and everything being in the same place, we're creating this class that's kind of holding everything, all of our data that we're going to use and our methods that we'll end up using. It's all getting kept in this class file now, and we're kind of accessing that class file to get what we need out of it. And again, that's why all this is public, so we can use it over here in our form. If not, it wouldn't work over there. If we called it private, this was private, it wouldn't work.
There comes the term. There you go.
Yeah, I'll spell it right sooner or later. So it's declared private, so it can't be used anywhere else. So if we look at our form, it's mad now because we set it to private. It can't be used outside of the class that it's in. We're trying to use it in this class called Form 1. Well, it's not liking that because we made it private, and then it can only be used inside this classified add class. But if we change it back to public, now it's saying go ahead, use it anywhere you want in our code. And you can see now it's all happy again because it's made public and can be used outside of that class. So now instead of just creating methods and everything else where our button click and stuff go, we're creating a whole separate file to hold all that stuff now.
It's making a bunch of objects. It's like, I don't know. Is it like the Big Bang or something? What do you think about it?
Honestly though.
Just a way of saying it.
I'm not sure I understand the Big Bang part of it.
Everything started in one place and expanded out, and like basically.
Yeah, that's kind of how we're doing. We started out small just to get the basics, and now we're expanding it to show all of what C# can do and what it will do. And like I said, this part that we're setting up is going to allow us to start talking to a database when we get to a database, because that get's going to pull data from the database and put it out on the screen for us eventually when we get to that point. And that set is going to set data that gets sent back to the database to get updated and whatnot and bring it back and show us on the screen. So this is just kind of a baby step on getting us to being able to talk to a database. But when you go out in the real world and you code web development, full stack development kind of stuff, this is what you're going to be dealing with all the time, are these classes. And I'll bring in an example tomorrow of some of the Java ones I used to work on, just to kind of show you how closely they are related. Just the syntax and some stuff is set up different in that. But let's go ahead and print out the second classified ad we had, and then we'll take a break after that. Yep.
Will I be able to like retake your test probably like tomorrow, because you might need
Hopefully I can get it graded by then, your lab's graded by then, but it just depends on how much time I have to get your labs graded. All right.
I could say like I won't be able to today.
No, definitely not today.
Got it.
So we'll do a label result. Dot text. We'll do our plus equal. Do string concatenation. I'm going to put a backspace here, or a space in the beginning of it, just so it's clean when it prints out. And we'll do kind of the same thing we did on the other one. I can just copy and paste. That's ugly. And of course we have to change it from our index of 0 to index of 1 to get that second one to print out. So now if I run this, make sure I have my window open. If I run this, create my ad, there I can see the used Toyota has 50 words and costs $4.50. The used Honda ad has 40 words and costs $3.60. And printing these out, we could print them out in a loop. So if we want to print them out in a loop, we could do another for loop. Classified ads length. And do label results. I'm just going to copy and paste this one here to save some time. But instead of using a hard-coded index, we'll use the variable for our index, the variable I. And this will print it out via the number. I'm going to go ahead and comment this out real quick. So now it should loop through here and print this out each time it loops through. And I need my plus on the front to make it work properly. So now if I run this, it should print both out through a loop. And it does. I don't have a break in there though because of it. So let me put a line break at the end here so it looks clean.
So basically with that,
excuse me,
as we make more objects, it'll just loop through all the objects and print them all out.
Yep, if we set our up here to our array length of 20, put 20 ads in, it just goes off this classified ads length. We know our length is 20 because we set it to 20. So it'd loop through 20 times and print that out each time.
Okay.
Let me run this real quick, and then so you can see now it says the used Toyota has 50 words, costs $4.50. Used Honda ad has 40 words, costs $3.60. And that's just printing it out with a loop instead of doing a couple, printing out the labels instead. I let the loop print them out. give me 1 second. So create a new project called Painting Demo. We'll go ahead and create it.
Oh, what now?
Painting Demo. So again, we'll go add our class that we're going to make. Add class. And we'll call it Painting Demo. Painting Demo. Again, it comes as an internal. We want to change that to public so we can use it as needed. Our instance fields. What did it say? We need a width, length, and a height.
I think so, yeah.
So we'll do private int width, length, and height. And I think we need one for what? Wall area and number of gallons.
What did you name the class?
Painting Demo. So it says constructor requires parameters length, width, and heights. Contains a field for wall area of the room and number of gallons of paint needed. So we need wall area. So private int wall area and a private int num gallons. So this one, I believe it says the room constructor requires parameters for length, width, and height fields. So we haven't done this yet. So far we've been using the default parameter, or the default constructor, I'm sorry. So we'll do constructor to set the instance.
By the way, you spelled like wrong.
Thank you. Length. I do that all the time. Set the instance fields. So now we'll do a public, and we're going to call it room. And so far we've just been using a default constructor like this. Well, we're going to add parameters to it now. And when you add more parameters than what it calls for, that's called what? Overloading a method. So we are going to overload this constructor. Ugh. And we're going to set
You don't have the types of players.
with the constructor, we don't have to.
Okay.
So we're going to do width equals width. So we want our width instance field up here to be the same name as our variable that we're passing in as our parameter. So length, height, and that's all we need to pass in for now.
Mr. G, were we naming the object painting demo, or were we naming it room?
Oh yeah, I did change it, didn't I? We will call the class room. Sorry about that.
No, all good.
I don't know why I guess I changed it. So sorry about that. The class should be called room. Our constructor should be called room because they have to be called the same thing. That's why mine was angry at me earlier. And on our little sheet here, it says the room constructor. So we know our class, the room class. So we have to call our class room. So if you got a red squiggly line, make sure your class, puppet class up here is called room and your constructor is called room. So we're going to make read-only properties. Does it say that on here? Include read-only properties for a room's values. So the room's values are that width, length, and height. So they want read-only properties for that. So we will do,
So we're making accessors, right?
yes, public int width. And you can see IntelliSense is pretty fast. It's already wanting to code it out for us. And let me put a comment above here.
Mr. G,
Yep,
I enjoy lecture time.
glad to hear it. I'll do it more often. Yep.
Is there a way we could come like rainbow by chance?
Do what?
Is it possible in the Python to come with the code to rainbow?
I'm not going to. You can try it. There's probably some kind of extension you can add to it or whatever. Coding's hard enough. I don't need a bunch of distractions in my code changing colors and catching on fire and smoking and everything else like that.
We'll make a program that adds emojis.
Yeah. So we got our width. We'll do our length.
Yeah, Mr. G, I thought we weren't supposed to return them when they was read-only.
What's that?
I thought we weren't supposed to return them when they was read-only.
The get returns it because it has to return it out to the screen. It has to put it back out for us to see.
Why not?
The set does not have a return because it's bringing the value in. But that get has a return to put it back out to the screen for us to see.
Yeah, I want to see if I can find the code.
And then height. So we got our read-only set up. And again, if we wanted to, we could do the, gotta do it before since it's commented out.
I just like to put, it's like good luck firing new boss. Maybe put it all on wingdings.
We could do something like that, but
I'm gonna be real. IntelliSense does enough for me on this. I know what it's doing.
yeah. So now we got our read-only property set.
And I finally understand what the references do. It's where it's being called later.
Yeah, so it's referencing it is
Yeah.
what it's doing. So yeah. So the room constructor requires parameters for length, width, and height. We got that. Parameters for our constructor, length, width, and height. The room class also contains a field for wall area and room number. We got that, wall area and number of gallons. Both of these values are computed by calling private methods. So now we got to create a method to get the wall area and the number of gallons. So again, our methods are private because we only want to use them in this class. We're not going to return anything, so we're going to call it void as our return data type. And we'll do a calc wall area. We're not passing any parameters in, so we can just put the parentheses. And this here is a method, just like we've been doing methods for the last chapter, chapter 6 part 2. Just creating another method. So we did one in the methods where we had to get some area, and we took length times height times 2. We're going to do that again for this wall area. So our math is going to be underscore wall area is going to equal, it's going to take our length variable, if I could get it typed out here, times 2, or length, I'm sorry, length times height times 2.
That's what, plus width times height?
Yep. We got to put the parentheses around them so it can calculate that one first before it adds the two together, because of course our math, it does parentheses first and then the addition after parentheses. So then we'll do underscore width times height times 2. And so we're getting the length and height of 2 walls and the width and height of 2 walls. Going to calculate that for our wall area. And then now we need a number of gallons. So again, we'll use another private access modifier since we only want it used in this class. Void calc num gallons, no parameters, and we're not returning anything. So we're going to do an integer divided by an integer, gives you an integer for division. So we're going to create a variable called int gallons, and that gallons is going to equal the wall area divided by 350, because it's saying 1 gallon of paint is 350 square feet. So we're going to take that wall area and divide it by 350. Then we're going to do an if statement. Say if wall area divided by 350 does not equal 0,
Could be like what, gallons plus or something?
Yep, just going to add an extra gallon as needed. And again, if you look at the if statement, we use that percent sign. What's that percent sign considered as? Yep, that's a modulus. The modulus takes this number, the 350, and divides it into wall area. And we're saying if there's a 0, if it returns no remainder, then that's all the gallons we need. But if it returns a remainder, that means it's more than 350 square feet, we need to add a gallon. So however many times it takes that 350 and returns it, we'll have to add gallons for it. So then what we're going to do is, take the num gallons and assign it the value of gallons. I don't know why, but I constantly lose my curly brackets.
I've been having that happen too. And I'm not sure if I'm accidentally like deleting it or.
Yeah, I don't know if I code over it or what, but it's frustrating.
Yeah, that always happens to me all the time.
Yeah, wink, wink. Trying to give you a hard time, but you weren't paying attention. So now,
How do you get modulus again?
the modulus is that percent sign here, and what the percent sign is doing is looking for a remainder.
So just percent sign.
Yep. So that percent sign is called the modulus. It divides a number into whatever we're checking. So we're taking 350 and dividing it into wall area. If there's a remainder, that means we got to add gallons to it. If there's no remainder, it means that it only goes in at the one time or equal number of times, and there's no remainder, so nothing will happen. So now we got to call these methods out of our constructor. So we'll go back up to our constructor, that public room int width. Actually, I got 2 more examples to do today. We'll probably get through this one. I'll do a couple more tomorrow. So we're going to call these these methods in here. So we'll do a calc wall area, and do our calc number of gallons. So now when we use this object, this room object we just created, it'll do some calculations for us. So we'll call those methods and do those calculations for us. That making sense, everybody?
Yeah.
Let's do gallons. Okay.
So now I mentioned that toString that we've been using, that some people use when we display things out to a label, and you get the variable .toString value that comes up. We're going to use that toString, but we're going to make it do what we want it to. So we're going to go down just below our last method. We're going to do a public because we want to use it in other places of our code. And we're going to use this keyword called override. This override is saying, yeah, we know you got a toString method, but we're going to override what you're using and use our own method in this place. So we're going to do a string toString, and that return base.toString. We're going to get rid of all that, but keep the return, and we're going to return it what we want to return it. So we're going to say,
Going to be like label result, something, something.
no, we don't even do that. So we're going to do $ string interpolation a underscore length times width room with a height such and such foot ceilings. And I'm going to concatenate this again just so it fits on the screen a little bit better. Has an area of wall area and will need num gallons of paint. So now that we got our class all coded out and our object defined up there with the constructor and what we need with it, we're going to go to our form. And we're going to create our form. So we're going to put a button on there. And our button, we're going to say view room data. Button, the BTN, I'm just calling it room data. Of course, we're going to need a label to show our totals. Call it label result. I don't want any value for text. So it should have been pretty quick and easy to set up. So double click on our button real quick. So now we'll start setting up the actual code for it. So first thing we got to do is we got to set up our array called room. And then we'll call it my home's rooms. We'll call it new room. So we're setting up an array just like we did in the last one and like we've been setting up arrays the whole time before. And we'll give it so if we want to, you know, we could code it out like we have been, my home rooms, my home's rooms, and then set an index for it, and then say equals new room, and then put our width, or is that what it was, width? Yeah, width. And you can see down here, when we have that overloaded constructor, it tells you what order and what values you need to put in there. So that's always a nice little thing to keep track of, because if you put them in the wrong order, it gets mad and will not like it. So we'll do width. And this is going to be mad because we're not actually passing any of this stuff in yet. Length and height. So normally we'd do it like that, but there's a shortcut way of doing this, and we've done some of it in the past. So like when we do our data, how we were populating some of these arrays, we can do something like this and go new room. And we're calling that constructor in there, and we're going to tell it we want the values of a 12 by 10 by 9 foot room. And I'm missing a semicolon. And I could just print that out with the label like we had been doing. I think it's room. That might not be quite right because of the object. result.text. Did I not call it that?
It's not saying that the table exists, even though it definitely does.
And it does. Oh, and that's probably because it's outside that button click. There we go. So room's probably not because it's the... Yep, give me 1 second. Oh, I need my homes, I'm sorry. Should be something like that. That might not be quite right. So, and then I'll go back for Jada. Which part you need? Top. You good? You good, Jada? Yeah. So. So I'm going to figure out why that's not wanting to display right. But anyhow, I'm not going to worry about that. That's because not what we're worried about in this. So if we look, it says an array of 8 room objects. So we got 1 room object created here. So we need 8 more. I'm just going to copy and paste these for right now. So it wants 8 of them. And then we need a for loop to get through those, but we're going to use a for each on this one so we can look at each one individually. So all I did, I took that new room that we had up here, the object we created, and just copied and pasted it 7 more times to get us 8 total.
I'm surprised they make it we put 8 in new room.
And you don't always have to put a size in there because we're putting the data in now. And then so for our for each, we'll do label dot result dot text plus equal I need to, is that right? Plus equal room dot toString and because that toString, we created that toString method over here to say what we want it to. when we do that toString, it should print out what it says here, because we're saying use this toString method and return this value out of it. So now, if I run this, hopefully, there it does it. So it's just doing it multiple times because we haven't changed anything yet. It's 396 square feet. Because it's over 350 square feet, we need that extra gallon of paint. So it's saying we need 2 gallons of paint. So let's go change some of these numbers up. And this one here, we're going to use a user input for it. So let's go back to our form. We're going to put a couple text boxes in here and a label.
We only need 2 because the height of the ceiling is always going to be 9, right?
Well, we can let them put the height of the ceiling in if we want, so we'll do, this will be width, the text box, txt width. So I'm just going to copy these two, Control C and Control V 2 more times and make some copies of them. Change that to length. Make that text box txt length, and then finally our height. And our text box we'll call txt height. So now we can let users enter some data, but to handle that, we got to go back to our array that we created. So instead of hard coding that in, on our second one, we'll put width, length, height, and it's not happy. Anybody know why it's not happy?
Because we're not using the underscores.
Yeah, we're not getting these values from anywhere yet. So we need int. We'll call it width equal. Did I do it again?
Yeah.
So width is going to get our text box from our width, and we got to convert it because it's going to come from a text, a string, to an int. So we got to convert that to an int 32. We want txt width.
Also just do .toString.
Do what?
Did you also do convert toString like at the end?
No, because we overrode that toString method, and so if you do, it could throw an error. It may not, but we don't want it toString because it's a string already. We need to convert it to an int to make our object constructor up here happy. So our constructor, we're saying in width and length and height. So we got to make that happy. So we'll do an int length, convert that, int height equals, convert that. So now our parameters are happy there. Let's change the size of our room a little bit. By 10 by 9 is fine. We'll do a 15 by 10 by 8.
It's also probably a good idea to add a line break after each room that you're staying at the bottom.
I think we did.
Yeah, did we not in here? Yeah, there's my line break right there.
Oh, I probably missed that in the design room.
We'll do a 6 by 6 by 6, like a little jail cell there. We'll do 20 by 20 by 10. So now if we run this, what time is it? 11:40. So now if we run this, if we try and just click on the button, it's going to break because we did not put that length, the width, length, and height in for that part we needed. So we need to put it in for there. So for width, we can do, I think Mr. G's video, he did like 100 by 200 by 9.
Yeah.
And so we click on our room data. It should work now because we are putting values in for where it's expecting these variables to be. Click on room data. A 10 by 12 room with 9-foot ceilings, 396 square feet. We already saw that. 2 gallons, a 200 by 100 room with 9-foot ceilings has an area of 5,400 square feet. 16 gallons, 8 by 10, 9 feet. That's under 350, so we only need a gallon. 10 by 9 with 9-foot ceilings, 342. That's under 350, so we only need a gallon. Square feet on this one is 400 square feet, so that's over that 350 square foot we were checking on, so it needs 2 gallons. 378 is over 350, so we need 2 gallons. Our little jail cell here is 144 square feet, so we only need a gallon. And that 20 by 20 with 10-foot ceilings has 800 square feet, and we need 300 gallons on that because it goes into 350, goes into 800 twice, and then it has a leftover, so we need to add another gallon to it to make it 3 gallons. Yes.
Can you go to the class here so I can see if you got one reference for the public impact, public input? Yeah, mine says 0 references too.
And more than likely, that's because we're not using the properties that width, length, and height because we're printing them out here to a 2-string. So on that label that we were trying to set up and had issues, if we called the width, length, and height there, it would probably populate it.
Okay, because when I try to run my application, it's telling me that object reference not set to an instance of an object.
Yeah, and it's more than, and these aren't being used just because we didn't print them out using the width, length, or height with those gets. We just took that width, length, and height and put them down here in this 2-string that we returned.
Okay, can you scroll all the way up?
I'm getting an error. It says input string is not in the correct format. So, yeah. Let's go to your class. Scroll up. Try to put the calc wall area above the calc num guns. See if that makes a difference. Close that correct format. Go to details. Go to details and see. Let's go look at your code real quick. Go to your actual. Yep. And it says no issues. Yeah. Go back to your class. You have height, capital H, that I'm trying to change that to lowercase. Put your underscore in front of it. I'll try and send it. So go to details again. System exception. Forms. String. Go back. So we get 20 paper frame match lines. Go ahead and close that.
Recording.